Morning.
Morning.
Good morning, Ty.
Morning.
Who's Galaxy A51?
That's Cody.
Codester.
Yes, sir.
All right, before we go over the homework, did anybody get arrested this weekend? Damn it.
Every time.
They were a little slow.
Hey, whatever happened with your police incident, Will?
She got kicked out of the campus and she's not allowed back on.
This is your mother?
What'd you say?
Your mom?
No. That roommate's girlfriend.
Oh, same thing, right?
She was big.
Man,
So-
one of these weekends, Will's going to jail.
I was
I can just tell.
I was on a Zoom call when you were telling the story. What happened again?
So my roommate was planning on leaving her this summer, not wanting to move in with her. And she got mad. She wanted to move in with him. He didn't want that. She decided if he's gonna do that, she's gonna act crazy until he lets her live with her. It went on
Acting
for
crazy. That always helps. Your case.
that went on for 4 hours. Then she eventually leaves the apartment. I lock the door, tells my roommate not to let her in. She bangs on the door asking for her stuff. So I decide to grab her bag of stuff, everything she's giving my roommate, hand it to her. She busts in. She starts saying, assault, get your hands off of me. So I put my hands up in the air, move back. She grabs her boyfriend, and then I leave. She told me she was going to call the cops. So I thought, I'm going to call the cops. I had about 20 minutes of video of her being crazy. I showed the police beforehand the video, and turns out her story never matched the video. So the police gets her moved away. She's fine. Then about 2 hours later, she comes back down wanting to talk to her boyfriend again and wanting her stuff. So I do the same thing again. She rushes me, grabs her boyfriend, brings her to his room. I call the police again. Turns out she lied to the police the second time, and they said housing was going to deal with it. So in the morning, I showed housing all the videos, and she got kicked out of housing, had 2 tickets, and they don't know if they're going to allow her to go to school next semester.
Either one of them?
Just the girlfriend.
Oh, okay.
Will, you still got these videos?
Yes.
We're gonna put them on eBay,
I gotta
on
s-
YouTube.
I got a sneak peek of these bad boys.
Oh man. Sheesh.
In one of the videos, she threatens to stab him.
Oh, wow.
We definitely gotta see these videos.
They're about 8 minutes long, and there's 3 of them.
Well, I'm glad you're okay, Will.
Yep.
Are you on campus housing, I take it?
Yes.
Okay. Okay, y'all. What do we do? Chapter 6 for today? Before we go over this, everybody listening?
Yeah.
Can I get an amen?
Amen.
From here on out, we'll plan on doing everything in person. So no more Zoom meetings. I'm not going to take attendance. After probably Wednesday, the remaining however many weeks that is will be for the most part just labs. And you'll see as we go along the labs we have left to do. Nothing too difficult, but it's going to be up to you to use your time wisely to get everything done. But no more Zoom on Mondays. Just plan on coming into class. Capiche? Okay.
Gotcha.
Today we'll go over chapter 6. We'll look at the next lab, which has to do with prox sensors. And we'll see what time it is after that. Okie dokie. Contactor fails to seat properly when energized. What do you think that would cause?
All of these.
All of them? Does everybody agree with that?
Yep.
Fine. A magnetic contactor is a magnetically actuated device for repeatedly establishing or interrupting an electric blank circuit.
Power.
Power. Mechanically held contactor requires only a pulse of coil current to change state. Is quieter than electrically held types. Ugh. operates more efficiently than electrically held types.
All of these.
What does that mean, mechanically held versus electrically held?
The coil isn't energized the whole time, producing the magnet, holding it closed. It either has a lever or something holds it in place.
Yeah. Yeah, and you guys won't have any of those in your trainers. I don't know that I've seen, well, maybe some in the field, but there's one called a latching relay. You seen that in the book yet? I don't remember if that's this chapter or not. But you will see those in Electech 151, which is troubleshooting, if you're taking that class in the fall. But there's actually two coils in a latching relay, a latch coil and an unlatched coil. So when the latch coil energizes, it only requires a quick pulse enough to actuate a spring-loaded lever, which holds the contacts closed. And then the unlatched coil, when that energizes, that mechanically unlatches the lever and releases the contacts. So it's a lot more moving parts. They're more expensive than just having an auxiliary contact electrically hold a coil closed, but it is quieter, works more efficiently. Motor load would be classified as inductive, capacitive, resistive, or nonlinear.
Inductive.
Inductive. I don't really understand the nonlinear part because motor loads can be nonlinear, but for the sake of the quiz, they want it to be inductive. Solid state counter has no main contacts, produces no arc, is silent in operation.
All of those.
Yep, and yep. Thermal overload relay operates on the principle that as the level of current increases, the temperature across the heating element
Increases.
also increases. Do you find that, like, going through this chapter, doing the work that you've done in the lab and learning how these things work makes the chapter make more sense?
Yes.
Yeah.
You? Yeah.
Yeah.
I'm more of a hands-on visual learner, you know, so for me to go through book work and then try to do the in-person stuff, it doesn't click as much as, you know, messing with it in the lab and then reading about how it works. Just as a curiosity question. As the distance between contacts increases, the resistance of the arc increases, voltage required to sustain the arc decreases, arc current increases.
Resistance of the arc increases.
Yeah. Isn't that kind of bizarre that there is a resistance there? If I have 2 points of contact and there's an arc between them, what's resisting current flow?
The air.
Yeah, the air actually has an ohmic value. It's very, very high, but there is resistance to air. And if the voltage is high enough and the distance is short enough between 2 points, it will arc across. Cool, huh? You guys have I shown you my video of me up in a bucket truck with underneath the power lines and it's arcing? I shown you that video? You want to?
Yeah.
Okay, remind me after the quiz. We'll look at it. It's pretty cool. Compared to IEC rated contactors and motor starters, equivalent NEMA devices, well, they're not smaller. They're not
Built
more
for higher level.
sensitive. They're built for a higher level of performance. Compared to thermal overload relays, electronic overload relays, all of them, right? They're insensitive to temperature changes. They're easily adjustable to a wide range of full load motor currents and they're more energy. Contactor coils are built to operate on which one?
Over a range of 85 to 110%.
Which means that if I have a 120 volt coil and I try to run it on 100 volts, is it still going to pull in? Like if for some reason voltage drop or for some other reason I'm energizing this coil with 100, what's 100 volts compared to 120? What percentage is that? It'd be 5/6.
83%.
83%. So what is 85% of 120?
102.
102. So if I put 102 volts on that coil, will it pull in?
Yeah.
Probably. That's the design of that inductance creating enough magnetism against the pulling against the spring that's in there to close it. But do you think that's a good idea to run it at 102 volts consistently?
Nah.
No, because somewhere around that range, you're going to start to get chatter, which means the contact's pulling in, but the strength of the magnetic field is not strong enough to hold it. It's just going to sit there and kind of chattering. Some of you have heard chattering in the lab. Do you recall? One or two of you have hooked up normally closed contacts to your relay coil as a holding contact. So when it pulls in, it opens that contact instead of closing it. So it sits there and tries to close and open itself over and over. That's called chatter. Anyway. Contactor coils are molded into an epoxy resin to do what?
Increase moisture resistance.
Yep. Contactors can be automatically controlled by very sensitive
Pilot.
contactors may be used for switching motor loads when separate.
Overload protection.
Very good. Can you imagine, like, not knowing any of this stuff yet and having to go through all this book work before we actually go into the lab? Whew. I don't know what I'm talking about, so I'll just keep going. In AC contactor coils, the current through the coil is limited by the length of the circuit, and reactance has a greater effect than the resistance.
Impedance.
Impedance. Sound familiar? eBay. Motors are subject to
All of
Look
those.
below.
what does service factor mean?
It's the amount the motor may be overloaded.
Yeah.
So it'd be like 1.15 or something like that.
It's 1.100, isn't it 125%?
That's the highest, wasn't it?
That's, I think you're allowed that by code. 125% of full load current. Let's look in here. You want to? How many of you use these on the job? For those of you that are working in the industry, pretty handy, right? Motors, Article 430. Flux capacitors, 1.21 gigawatts. Full load current in amperes. 32. Of course, it might just tell you what the number, oh, branch circuit conductors. Okay, so that's for feeding a motor. Use 125% of full load current to find conductor size. So I don't know what I was thinking, service factor. I'll look this up later. Gotta be in there somewhere. Anyway, let's go on. What is
Are you
FLC?
humming bare necessities?
Yeah.
Ah,
You like Baba Black Sheep instead?
from Will.
You don't like my voice?
No, yours is fine, but Will's is different.
Nope, nope, nope. You've already dug yourself a hole. I want to hear it from Will. Fine. FLC stands for full load current of a motor is
Running current under full load.
running current under full load. Current drawn by a motor. It's not low on starting, it's very high. It's not an inaccurate measurement of motor load, it's actually an accurate measurement of motor load. Both A and C.
Yeah, it's accurate and inaccurate.
Oh, all right. Current rating of a contactor starter is the rating for what?
Each individual contact.
Correct. The overload relay contact is connected in series with
The coil.
coil. Purpose of overload protection on a motor is protect the front.
All of these? Or is it just ground faults?
I think it's just sustained overcurrents, but the other two are like included alongside overload or something like that.
Short circuits and ground faults are going to be protected against by overcurrent protection devices, fuses, and breakers. The overloads how does an overload work? You remember when I explained that? I showed you the backside of the overload heater. as it warms up, it trips and opens up. So the only way that's going to happen is with sustained overcurrents. So if you have a ground fault or a short circuit, if it's sustained long enough, it might heat the windings up, but really, if you have, oh my goodness, if you have a ground fault or a short circuit, you're not going to get any current through the windings of the motor, right? So it's probably not going to overheat. I guess in a weird circumstance it could, but sustained overcurrents is what overloads protect against, because sustained overcurrents will heat up the motor. The two circuits involved with operating of a magnetic coil contactor are, you guys should know this one from a long
Power and control.
Power and control.
power circuit and control circuit. When a motor starter coil is de-energized,
Gravity and spring tension open the main contacts.
when the magnetic starter reset button does not reestablish the control circuit after an overload, it's most likely because
The overload
Overload.
trap doesn't not cool sufficiently.
right. So on your motor starters, you've probably all seen a little white reset button. If a motor actually, and I can't really simulate this without damaging motors, right? Because you don't want to consistently overheat motors. But if it did overheat, you would see a little trip indicator on there. And if you reset it and it retrips, that just means it hasn't cooled off.
That, the one option was for the heating sensor went out. The overload heater burnout. Is that only like the manual? Is that the push button? Is that like electronic or how's that?
Can you ask that
What about
again? I couldn't really hear you.
The problem, the last option was the overload heaters burn out. If you have them, have the overload heater for that. Are those overheaters replaceable or if they
Yeah,
burns
the
out, you have to
heaters are
replace it?
replaceable, and they have, it's very rare that an overload heater will burn apart, but I have seen it. But if it's burnt out, that doesn't necessarily mean it tripped, that it opened up that contact. You know what I mean? So. Does that answer your question?
Yes.
Okay. It's Monday. I'm moving a little slow today. All right. We will plan on taking the quiz for chapter 6 on Wednesday. What lab are we on? 13?
Yes.
Were you gonna show us that video of the arc flash?
Oh, thank you for reminding me.
Well, that quiz on Wednesday, is that like 2 days away Wednesday? Are we doing next week with chapter 7?
2 days away Wednesday.
So is our chapter 7 homework due before then?
No, chapter 7 is next Monday.
Oh, so the quiz is just over chapter 6.
Oh, wait a minute. 1, 2, we go 1, 2, 4, 5, 6. Yeah, we'll do 6 and 7 the next Wednesday.
Okay, okay.
I'm glad you caught that. I forgot we were doing these two at a time. So the quiz will be on the 5th, not the 28th.
Sounds good.
And that'll cover chapter 6 and 7. Hey, there's eBay. Okay, so this is me in a bucket truck in Morton. We were changing out light fixtures. And it's underneath the one of Ameren's distribution lines overhead. So you're talking about probably hundreds of thousands of volts overhead, which creates a lot of inductance, magnetism, static. And what you're seeing in the video is the pole itself is grounded, right? So that's a good path for any inductive current to go to earth. And as I approach the fixture with my pliers, my clines, you're seeing inductive, let's see, how do I want to explain it? It's looking for a path to ground, right? So if you can imagine hundreds of thousands of volts alternating current up in the air, just like a transformer would induce a voltage around it, right? With another mutual induction, all that stuff from AC theory. You're seeing that inductive current, and it's not much current, it's really just a static voltage, go through my pliers and to ground through the pole. So I'm not grounded. There's obviously no current or anything going through me because I'm in an insulated bucket truck. But what question was it that reminded me of this?
The distance.
The
between-
distance, yeah. So at some point when I get close enough to that fixture with my pliers, you'll see it start to arc. And you're seeing current flow through the air. But I'm not grounded, so there's no current going through me. That's how I don't get hurt. Plus, I'm wearing gloves. And they're only 600 volt gloves, but or 1,000 volt gloves. Anyway, here it is. See the power lines up ahead there. Can you hear it? Pretty cool, right?
Yeah.
Wicked.
Wicked sweet, man.
Nice.
Now what are we doing? This stuff. The donut conveyor. All jacked up. I'm not sure why there's a gap there. You get the point. Anyway. Uh, um, all right, so what's going on with this donut conveyor? What do you think? What do you think the point of it is? What happens?
Is like the proximity sensor like sensing that like a donut's underneath and then like frosting would go on it or something?
Yeah, two motors. So what do the motors do? It's labeled on there.
The first one is moving the conveyor.
Yep.
And then the second one is frosting the donuts.
Right. So motor one is your conveyor motor. Here's the motor starter coil. You hit the start button, the green light turns on. CR1 also energizes. So hit the start button and this is on. The green light turns on and CR1 energizes. So there's your motor conveyor spinning, your conveyor's turning, donuts are coming down the line. MS1 has been energized, so this closes and keeps current flowing through there and through the green light and through CR1 coil. What happens to CR1 contacts when CR1's coil energizes?
Yeah, contact. They normally open when the proximity switch closes, and then
Right.
normally closed, the yellow light opens.
That closed and this opened up. So the yellow light turned on. Now with this guy closed, whenever you energize the prox switch, the red light will turn on and MS2, the frosting button, the frosting coil, frosting motor will energize. So basically what happens is the first button starts the conveyor, donuts come down the line. Every time the prox sensor detects a donut is in front of it, it will energize the frosting and the frosting will come down, squirt on the donut. Okay. I wanted to look at prox sensors are pretty easy if you have an understanding of how limit switches work. And there's a reason that it looks like a limit switch with a diamond around it because it works the same way. It's either normally closed or normally open. And if you remember from your book, I don't remember which chapter, but there are different types of prox sensors. There's capacitive, inductive, photoelectric. On my trainer behind me, there are a couple different types, and we'll look at those together. I'm about to show you a really sophisticated method of looking up wiring diagrams. Are you ready? Google. And you might think I'm joking around, but in future classes here, you're going to be expected to do this kind of thing. If you come to me and say, hey, I know I'm supposed to hook up this prox sensor, but I don't know how to do it. I'm going to say, okay, and then I'm going to walk away because I'm a jerk. This is a Easy Beam S30AW 3FF600. S30AW 3FF600. What did I say it was? S30 3FF AW 3FF. Tools. More. Settings. I don't remember what it is. Diagram. Woo, look at that. That looks like a good one. Here it is, featuring Easy Beam technology. So what is mine again? S30. S30. AW 3FF 600. The one below it is a Cutler Hammer solid state E51 SAO. All right, so let's look at the S30 AW. Three FF 600. Right here. Output LO. Range 600 millimeters. Cutoff, so about 2 feet. Infrared 880 nanometers, whatever that means. It's probably the wavelength. Fixed field, blah, 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 blah. Okay, here's how they work. Device setup. color sensitivity specifications, blah, 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 blah. Wiring diagrams. And I have, oh, it's not hooked up yet. I got a black, brown, and a blue. Probably gonna be this guy right here. Which means that my 20 to 250 volt AC, which is what's kind of cool about these, I can operate it on 24 volts AC or 120 or 250. Anyway, looks like brown and black are normally open, so brown's going to be common. Black is going to the load, which I'm going to use a pilot light. And blue is your plus voltage. So remember that. Wait a minute. No, blue is common. Brown. Am I reading that right? Blue has to be common because it's common with the load. Yes. So my plus 120 will be brown. Blue will be neutral. Black will be the going to the load. Well, sometimes people call that the signal wire. So I'm going to hook this thing up and show you how it works. What do I have going on? Timers. All right, what I don't know yet is if that has to be a reflective surface for this to pick up. We're going to find out. So what did I say? Black is the signal.
Yeah.
Blue is common.
Mm-hmm.
And brown is plus 120.
Yes.
Okay, so there's my prox. Blue is pretty easy. That's the common of 120 volts. So that's going to go over to my neutral bar. Do that now. You in class? Yeah. Cuckoo, cuckoo. Can I get a hi?
That had to be Will.
Yeah.
Is there a bathroom around here?
Yeah, I think out in the hallway, maybe.
Are you here Friday? Yeah. Can you watch my clients on Friday? You take it out. Behind or something. Got to they show up for that. I can make. I'm renting a tractor. For what? Like maybe Friday and play. For what? I'm gonna dig some stuff up and move those logs and all that stuff. Sweet. So I got for the weekend if you want to come in and play. What kind of tractor? Make a backhoe loader. You're joking. No, I'm dead serious. You want to come over and play? That sounds like fun. Bring the boys. Yeah, let's tear some stuff out. I'm serious. What are you digging? You know those, you know that right in the middle of the driveway that yeah, or just bumps that I'm getting rid of that. Just flatten it out. Flatten that out. And I also got 2 other mounds. I'm getting rid of them. I'm gonna fill them a little by gully, just kind of. Sweet. And then I gotta move those logs. I gotta get chains and move those logs. That's cool. Yeah. More this weekend and play and have it all weekend. All right. But Friday, I'm gonna start Friday. So you can watch my people. Yep, I got you. Thank you. All right, what's my plus 120? Brown?
Brown.
And where's the black one going?
The load or the signal.
All right. Okay, so this wire here is coming off my stop. So I'm gonna take that one up to brown. And all I gotta do is take the signal wire and go up to one of my lights. What color light do you want it to be?
Red.
Red? Okay. So what should happen when I turn that disconnect on is I put something in front of that prox sensor and the red light will turn on. Ready? Uh-oh. picking up the, there we go. It was picking up the C channel. So, whoop, whoop, whoop. Pretty cool, right?
Very cool.
Okay, the other one. There's actually a little diagram on here, but I would suggest looking up a diagram so you just get in the habit of doing that. Smells a lot like your limit switches do. And it's got 1, 2, 3, 4. So I'm assuming you have the option to wire this up either normally open or normally closed. But this just pulls off, and then the target itself is actually on top. So that's what you need to put something up here. I think this is an inductive one. So in order for this to work, you'd have to put something metal up here, but we will see. E51 south. It's probably just going to show the same. Same diagram that's on the front of this thing. Oops. Two wire sensors, 264 volt AC or 120. Sure. Okay, so this actually is the same diagram as is on the front of the sensor itself. This guy here. So it looks to me like, and I don't pay much attention to the colors they tell me to use. I need to go to 1. Plus voltage. What's 3 and 4 for? I don't know if this means that 1 and 2 are normally closed and 3 and 4 are normally open, or if 3 and 4 just have no function with this. But it shows it as a normally open prox. So I'm just going to hook it up. This pin 1, I'm going to bring in 120 volts, L1. Pin 2, I'm going to take that to either the green or the yellow, you can pick. And then the neutral makes its way back through the shared neutral wire. So I really only need 2 wires for this thing. You son of a bitch. So this is coming from 120. I'm gonna land it here with the brown because that's where I brought 120 over from the stop, and the stop's already got 3 wires in there, so I'm just gonna tag it in right here. Right, Chandra? My other one needs to go to the load. What's my load in this case?
Yellow light.
Yellow light? On the diagram, what about, where's my neutral? Neutral is taken care of on the load side of the load. So my neutral coming from my load is the shared neutral coming off of the lights, right? So that's already done. So put this bad boy back on. I think this is an inductive deal. Find out. Okay, so I've got power. There's actually a green LED on the photoelectric one too, but this is saying, hey, we're good. And my finger is not doing it. So it's inductive. I'm going to put something metal in front of there. Oh, there it is. Cool, right?
Cool.
So armed with that information, you should be able to do this lab. Now, I don't know what kind of prox sensors you have on yours, but all it is a limit switch that's kind of fancy. Right?
Right.
All right, well, Wednesday, come on in. We'll look at variable frequency drives, and I'll show you the labs you need to do associated with those. If you want to take a look at the VFD homework, you can. Let me see what I'm doing. VFD homework. So this homework is based on these learning activity packets. If you click on this, the instructions should say. They don't. All right. To do this VFD homework, go into course content and go lap 16, lap 17, and lap 18. These are the PDFs that you need to do that homework. And I don't know if you've seen these before, but they're really straightforward. Your VFD homework will be based out of these PDFs, and all these are set up with objectives, and they teach you a little bit about variable frequency drives, how they work. And Wednesday, I'm going to go through a little PowerPoint with you. There's no quiz over that PowerPoint, but it's just something that I put together to help you understand how VFDs work. So you'll go through this PDF to do the homework. And then these learning activity packets are also going to be, oh, that's nice, are also going to be used to use the VFDs that are on your trainer. And they go through how to set different parameters and all sorts of good stuff. So anyway, if you wanted to work ahead and go ahead and look at that homework, these are the PDFs that you're going to use for that. 10-4.
10-4.
All right.
Everybody happy?
Very happy.
Yes, sir.
All right. Well, you have a lovely rest of your Monday, and I'll see you Wednesday here.
Sounds good. See you then, Zach.
Thanks, Zach.
See you guys.
So yeah.
See ya.